Hello everyone, hope you're doing well. Welcome back to my channel. Today we're at day 9 of the January daily LeetCode challenge, and from the last few days we are having the question on the topic of try, that is string matching, and which could also be done using the topic of try. Okay, so in this particular question what I've decided is that I will show you both Python and Java solution. At the same time I will be teaching you the data structure directly, that is a try data structure. I will not be showing any brute force solution or any string matching kind of solution, which I guess you can do on your own. Okay, that is nothing major in that. Today I will be showing the whole data structure of try. Okay, we will be learning the in detail of why this type of questions are exact application of try data structure, and after that I will be showing you a detailed solution from scratch onwards. Okay, and we will try to see why this is most optimal solution in this particular case. Okay, we will see that now. I'll show you both Python and Java. So yeah, if you are someone who is following Java very particularly, don't worry, you have something in this video. Okay, you have something to learn from this video. Now let us begin the question. It is going to 2185, counting words with a given prefix. Okay, remember this is the exact application of the try data structure. Try is nothing but a tree, but yeah, we are using this for these strings. Okay, to predict the what could be for example, if you are typing for example pre, let us say you are typing this word pre. Okay, so what it will do is, inside the data structure what it will do is, it will search for okay which all words can be completed using this particular prefix. Okay, so it will give you the words which start with pre. Okay, so all the words that start with pre will be, so we might be seeing that in Google search autocomplete features, or in dictionaries these kind of features will be there. Okay, even in URLs this kind of feature will be there, it will be auto completing it. So that is coming from this data structure. Okay, so let's see this question now. It is 2185, count words with a given prefix. You are given an okay, let me zoom in. You are given an array of strings which are called words, and a string prefix. Okay, now return the number of strings and words that contain the prefix as a prefix. Okay, fine. A prefix of a string s is any leading contiguous substring of s. Okay, we'll see that whole thing now. So don't worry if you're not understanding any part in this question, there's nothing to worry here. I will be showing you everything in detail starting from scratch. So just pay attention to what I'm saying. See, these are the words given to you. Okay, yeah, these are the simple words given to you, and among these you'll have to tell that which all words have this particular prefix. Okay, what is the meaning of prefix? Prefix means that in this, if any of the words start with this, okay, start with this exactly as it is, then we can say that yeah, that particular word is having this particular word as its prefix. So we will have to count that word. Okay, that is the whole question. If you see, they have underlined it very nicely. If you see the word number 2, which is at index number 1, and similarly the word number 4, which is at index 3. Okay, these two words have this particular word as a prefix. For that reason the output is going to be 2. So idea here is, we will have to rank among all these words which of the words have the given input, this one, as their prefix. Okay, we have to tell the count of that. Okay, this is the question, right? You can go through the definition of all these things, but I feel the way they are mentioned is very complicated. Okay, you will be feeling that okay, I know, don't know, something like that. There's nothing to worry. Prefix is something that you might have learned in your English language also. Prefix of these things will be, you will be learning in English language also. Okay, in programming also it's exactly the same. Prefix means a word which is starting with this word. Okay, as simple as that, right? So what we have to do, see, if you do a brute force, what you have to do, you have to go to each of the strings. You have to keep checking here that whether this starts with this or not. So yep, you can do that, but I will show you something very different today. I will show you the try data structure of it. Okay, so I hope the question is clear to you what we are trying to do. We are going to parse all of these words, and we'll have to tell the count that among these words which of the words are starting with this particular word. Okay, so which of the words in this have a prefix given as this particular input. Okay, fine. Now let me show you the data structure which is try. So let's see, this is the try data structure. Okay, I am showing you a link from Geeks for Geeks, because the diagram is very much simple here. So that's why I'm showing you from here. So credit goes to these Geeks for Geeks in this. Okay, now, so these are the words which they are even in this particular data structure. Okay, so what are the words a and d? As you can see, this is the root node. From here, if you put a arrow starting with a, it will show the a and d. Okay, and similarly, if you see the word a and t, so you see a and d and a and t have a and n in common. Okay, so for that reason, if you see a and d and a and t have a, we can say that they have a common ancestor, which is a and n. Okay, so that is how we can say they have a common prefix. Okay, so just pause this video, go through this data structure for some time. So what we are trying to do here is that if a particular word has a prefix in common, we will not be storing them into separate ways. Okay, what we'll do is we will store in a common way. If you see here, when we reach n, there are two ways now. We can either take a d or we can take a t. Okay, so let us say you are typing a and n in your let us say your browser, or in somewhere in your text, in your input text. Okay, so what if you are using this particular database, what it will do, it will predict that either it could be a and d or it will be a and t. Okay, something like that. So idea here is it will for any two words which have a common prefix, they will have a common ancestor. Okay, as simple as that. So what the exact same thing that I am also going to implement, the only change that I am going to bring here is that if you see here with a, like for every node I am also going to maintain a prefix count, that is the frequency count, that is how many words have this thing as their prefix. Okay, so that is the only additional thing that I will be doing, which is not shown in this diagram. Okay, this diagram just shows the path, the for each of the words we'll have to take to reach the end, to reach the leaf node. That is fine. But what the additional thing that I will doing is at each node level I will be also storing a frequency parameter. Okay, there's a data member called frequency that will tell me how many words till now have this particular frequency. Okay, so let us now quickly begin. So first I will be showing you in the Python, and then we'll going over the Java. Okay, so yeah, this is the node. What is a node? If you see in this diagram, each of this green color circle that you're seeing is a node. Okay, so each of the nodes is going to have one of these. Okay, so see here, it will have a next character. Next character basically means that it will have a pointer to the next character. Okay, one thing that I did not tell you is that in this particular input all the characters are going to be in lowercase letters. Okay, and obviously the wordings are very small, but obviously I want to tell you one thing. See, if you want to learn something, please do not see these kind of constraints, because see, if you see it's up to 100, you can try brute force, that is fine. But my aim is that, because I promised you 1 or 2 days back, that I will be showing you a question in which we will be implementing the try data structure from scratch and we'll be solving it. Okay, so because this is such a question, unfortunately it's an easy one. Still, the solution that I am showing you, if you apply to even hard problem, that will be solved. Okay, you will not be facing any time limit exceeded errors for that. Okay, the only thing that I want to tell you is that all the letters are lowercase. Okay, so at most you will have 26 keys for each node. So that is the only thing that I want to tell you. So see here, each node will have basically a pointer, that it can have at max 26 pointers, because see, from the current node, if you see, there can be pointers to a till z, right? So there can be only 26 pointers. So that is the basic idea. So at that I'm storing using a dictionary in Python. When the Java solution comes, I will show you. I will be using hash map for that. Okay, in Java. Next, as I mentioned, I will be also creating a frequency. Okay, that is how many words have come till now. That's how many words have this particular word till now. That's this particular prefix. Okay, so that will be the prefix count, frequency. So initializing this with one. Okay, as simple as that. This is just a node class, but yeah, this is not the whole thing. Now we'll start the try class. Okay, remember the solution will look very simple. If you see, the solution is just 4 5 lines. So just pay attention to the basics that we are discussing now. This will be very clear to, even you can do this in other solutions. Okay, if you want, you can use this even in yesterday's question and the day before yesterday's question. Remember that part. So please pay attention to this very very keenly. If you see what we are doing next, now we are starting the try class. Okay, in this what we are doing, first of all, the init function. What is init function? Init function is basically implemented, that it's a constructor, like as we call it in C++. So whenever object is created for this particular class, this particular function will be executed. Okay, so what it will does, it will do is, see, since a try should have a root, so first we are creating a root. Okay, as you can see in this diagram, this red colored node what you're seeing is going to be the root. Root will basically have the link to all the words, okay, which are starting. Okay, as simple as that, you can think it like that. So as you can see, this is going to have the, I'm creating a root, okay, which is going to be again a node. Okay, node object. But since root is not going to have, see, root is not a part of the word as such, it just to track the words. Okay, for that reason, by default, I am setting its prefix frequency as 0. Okay, normally it will be 1. Whenever node is created, by default the frequency will be 1, but for this root, only for root, I am going to keep it as 0. Okay, as simple as that. Next, we are going to have a function for insert word. Okay, insert word, what we are going to do is, see here, it's going to be very very simple. I'm going to take the current root. Okay, then I'm going to check if the, we are going to each character of the word. Okay, I'm going through each character of the word. I'm just going to check if the current character, okay, if it is there in this or not. Okay, if it is there in this particular data structure or not. If it is not there, that means we have not seen any word till now which has this particular prefix. Okay, for that reason, now we are going to create a new word out, that is a new node out of it. Okay, to store this particular character. Okay, if let us say this condition not true, that means we have already seen a word which has this particular prefix. Okay, in that case, what I'm going to do, see, remember, when you create a new node, what will happen, this prefix frequency will already be set to 1. Okay, that is when we create a new node. Let us say this is not the case, that is we are not seeing this for the first time, we already have a word which has this same prefix. So what we are going to do, we are just going to do prefix frequency plus equal to 1, that is we are incrementing the prefix frequency by 1. Okay, as simple as that. So for each character we are going to do this. Okay, that is, we are going to insert each character into this particular tree. If the node is already existing, that is fine, just increment its frequency. If it is not existing, create a new node whose frequency by default is going to be 1. Okay, because this is how it is initialized. Okay, next, so if you see this what is being done in this particular function, okay, then we are going to each of the next nodes. Okay, then for each character we are just inserting it in my in my tree try, right? After this, see, once I will show you this, don't worry, I will show you this. But the idea here is for each of the words in my answer, if you see here, all these words, for all these words, I am going to call this particular function, okay, insert word function. Next is the prefix frequency. This will only be called for this particular thing, okay. This will only be called for the frequency given to us. That is the prefix given to us, okay. If you see this part, okay. So what it does, it's very simple. It's almost same as the previous function, but only thing is if see here the else condition is when we already have it. Here the if condition is when we don't have it. So in this case, when we don't have it, okay, we'll have to return 0. This is what we're doing here. Okay, same thing. First take the root as it is, then okay, this is not needed. Basically, you can remove this part. Okay, let me just comment it out, right? I'm just commenting it out. This is not needed. Now see here for I in prefix. That is, I'm going through each character of the prefix. If this character is not a node or next char, okay. If this is not here, if it is not here for the current node, that means we have not seen a word till now where we have this particular prefix. So we'll have to return 0 because the prefix is not found anywhere among all the words. Okay. If this is not the case, that is this particular character is present. So we'll have to just go to the next character. Okay. As simple as that. Then once we end, okay, once we end, remember once we end, we will end at a particular node. We'll have to return the prefix frequency for this particular node. Okay. So that is going to be our answer. So what is the solution going to look like? See, this is the main function in which this that will going to in the when you start the idea here is, see, all this whatever I've shown you till now is created by me. Okay, in by when you open this question for the first time, you will only be given this particular part. Okay, only this particular part. So you will have to just write this part. First of all, I'm initializing the object of try data structure. Okay, that is, I'm creating object for this particular class. Next, what I'm doing is I'm going through each of the words, okay, given in here. Okay, I'm just checking whether the first character of the word is equal to first character of the prefix, prefix, uh, prefix given to us. Okay, remember, even if you don't do this, still it will work. But I did just optimization. Remember that the idea here is, see here, for example, because it is starting at a, okay, so obviously the words which don't start with a, they are not needed at all, because that can never have a prefix like this. Okay, because it is starting with a, these are not starting with a. Okay, so these are of no use to us. Okay, this will never be part of the answer. For that reason, I'm just checking if the word of 0, okay, is equal to prefix of 0 or not. Okay, only if it is the same, that is the first character in my word and the first character in my prefix are same, only then I will be inserting that particular word in my try. Okay, this is how I'm inserting it. If you see, I'm using this particular function, insert word function. Okay, as you can see here, insert word function. So try dot insert word, and then I am inserting the word, okay, as it is. Next, what I have to do is, see, I'm inserting all the words. Remember that part. Every word will be inserted. At last, remember, after all this, let me give enter here. Once this follow up is done, only then I will be calling this prefix frequency function only once. Okay, this is the function I'm talking about. This will be called only once. Okay, this is a function. Here, this will be passed. Okay, the prefix given to us will be passed here, and this whatever this function returns, okay, will be the answer. Let me quickly run this and show it to you. Okay, that you have a better clarity of what I'm talking about. See here, as you can see, this is clearing all the test cases. Okay, I've already submitted this solution and it worked. Remember, I am not giving you the brute force way. I am giving you the optimal way directly. Remember, this is exact application of the prefix tree, because as I've showed you, the words having the same prefix can need to be stored only once. That is, you are saving your space complexity. Remember that, and at the same time, you need to process every word only once. So this is, if you see here, I am processing the words here only once. If you see, this is where what I'm doing. I am processing them only once. Okay, after that, for the given input, I just need to use this particular function, which again will process the word in only once, and then I will get the answer. Okay, you don't have to go through each of them and process them again and again. Okay, so okay, this was the Python solution. Let us talk about space and time concept. Then we'll go to the Java. Okay, so if you see here what we are doing, in the worst case, what will happen is, see here, we are ultimately storing every word, but remember, if the word have the same prefix, they are stored only once. Okay, let us say the worst case comes where none of the words have the same prefix. Every word has a different prefix or different characters. So in that case, we have to assume something. Let's say there are n total words, okay, in the string. Okay, then L with the maximum length of any string in the word. Okay, so at max, what will happen? See, in the data structure, we'll store n into L words, okay, in total. Okay, so that is why in the time computer also we are getting n into L. Okay, so that is what it is. And the length of the prefix, okay, let m be the length of the prefix. Okay, so since we are already processing that also, if you see in this part, we are again processing that. Okay, for that reason, that will also be part of the time complexity. Let me zoom in and show you what I'm talking about. See here, it is going to be n into L plus m. Okay, why? Because the idea here is, in the worst case, what will happen is, if there are n total words, and let us say all of them are having a different prefix, and let L be the maximum length. Okay, Let me just zoom out. Yeah, let L be the maximum length. So in that case, the total number of words, that is the total number of characters that I will have to store in my data structure is going to be n in 12. Okay. For that reason, n in 12 plus m. Why m? Because remember that is also being processed here. Okay. But remember, this m will not be part of the space complexity. Okay. So if you can see here, it is space complexity is going to be n in 12. Time complexity is going to be n in 12 plus m, because for m we'll have to process it, but we are not storing it. Okay. As simple as that. So this n will only come in the time complexity, but not in the space complexity. Okay. This is just assumption. Okay. Mostly this will not happen, because the trie data structure will work optimally only if the words that we're using have some common prefix. Okay. So you will save some space in in storing the common prefixes. Okay. As simple as that. So this was the Python solution. I can give it to you in the comment section. Just go and try to understand it once. Okay. Here I'm not given any print statements as such, but you can do that on your own. Try to understand what is happening. Okay. Next, coming to Java, exactly same thing I'm going to do in Java. Okay. Let me just zoom out once. Yeah, if you can see, I'm just creating a node class, as you can see here. So here we are going to have here, as you can see, I'm storing a map. In my Python, I had a dictionary. The same I'm going to achieve using a map in Java. Okay. So this will tell me the link to the next characters. Okay. As you can see, the key is going to be a character. Okay. The value is going to be a node. Okay. Node is, remember, the class itself. Node is going to be the class itself. Okay. It will store a pointer to this particular node. Okay. As simple as that. And it will store a prefix frequency, as we have seen in case of you know yeah, in case of Python. So one thing that I want to tell you is that, see here these things I'm declaring directly inside the constructor. Okay, that is the init constructor. Here I did not declare them again in the class, but in case of Java, they are different. You will have to declare them here separately, and then you have to initialize them separately inside the constructor. So this is how the constructor is written in Java. Okay, as simple as that. So here I'm initializing this is equal to new hash map. Okay, if you have a idea of how many words can be there, okay, how many frequencies can be there, just you can make a entry here also. You can give a number here also. I have not done that, but yeah, you can give that. Okay, as simple as that. Because the idea here is next car is going to store almost 26. Okay, so maybe you can give in the number 26 here. That's up to you. I'm just giving the idea. Just test it on your own once, but I'm sure that 26, if you give, it will work, because there are only lowercase English characters, so 26 should work. Okay. Next, at each level I want to store the how much this particular prefix is there in how many words. So that will be stored using this. Okay, prefix frequency, I'm initializing this with 1. Okay, as simple as that. So whenever node is created, these two things will be initialized as it is. Okay, next I'm starting the try class. Okay, so first I'm creating a root will be of the node type. Then I'm creating a constructor. What is the constructor going to do? It will initialize the root. At the same time, for the root, it will mark the prefix frequency equal to 0. The reason is, I have already explained the Python also. See, root is not going to be part of the word. Okay, it is just a I can say a setup to hold the words together. Okay, as simple as that. It is just for our convenience we are hiding it, but it is not having any real significance in terms of a prefix. Okay, so for that reason, its frequency will be 0. Remember, root is not going to store any character as such. Okay, it's not applying any character as such. It's just for us to keep a hold of the data structure. That's why we are creating the root. Okay, as simple as that. Root will not be storing any character. When you instance, if you go through the code that I'm giving you, you will get to know that this particular root is not going to store any character. It's not meant to store any character as such. Okay, this is just to to give a link to the rest of the data structure. Okay, as simple as that. Next is the word insert word. Okay, this thing is exactly same as what I've done in with Python. Same thing. I'm taking the I'm creating a separate variable to track the root. Okay, I'm going through each of my characters of my word, and then if the character is not existing, I am creating a new word out of it. If it is existing, what I'm doing, in the character that is in that node which is existing, I'm just going incrementing the frequency by 1. Okay, so if you see here, let us say A and T and A and D. Okay, A and N are common, both of them. So for these two, what will happen is, the new nodes will not be created, but the existing nodes, the prefix frequency is going to be increased by 1. Okay, and for D and T, a separate node will be created. Okay, as simple as that. So this is the part for that. That's how it is happening. See, I'm not going to go in detail of everything, because see, I already explained the Python solution in detail, and these things, what I think is that only when you go through it you will understand, because even if I explain a lot, it will not be much useful to you, because see, I can give you the code, go through it and understand. Once you go, and then if you see the video, I guess that will be the best way how you will learn this. Okay, as simple as that. Next, if you see, what I'm doing is, this function will be called only once. It will What we'll do is, we'll pass the prefix here, and then we'll see whether this prefix exists in any of the words or not. If it is not existing, we'll return 0. If it is existing, we'll return the count of how many words have this particular prefix. Okay, the exact same thing that we did in the previous function, like this exact same thing we are doing. But only thing is, in this if condition, if you see, Here we are checking if it is not existing, we're creating a new node. But here what we'll do is, if it is not existing, we will return 0, because if the prefix is not existing in the whole data structure, that means none of the words have this prefix. So we are returning 0. Okay. If it is existing, we are just going to the next node. Okay. As simple as that. Once we end, that is, if you see, once this for loop ends, we will be stuck with a node. We will be there in some of the last node. Okay. In that last node, whatever is the frequency that we are going to return. So that will be our answer. If you see the main function, this is the function that will go into you when you start this question for the first time. Okay. So this is the class and the function that will go into you. What you have to do here, initialize the data structure try. Okay, create object out of it, go through each of the words, just check whether the 0th character of the word matches with the 0th character of the prefix given to us. This particular prefix I'm talking about. If that matches, insert that word in the try. How you have to insert? You have to use the insert word function. You have to pass the word and you have to insert it. Okay, simple as that. Once we come out of this world, what we have done, we have inserted every word which starts with the first, which has the first character same as the first character of the prefix. After that, what you have to do, you have to just call try dot prefix frequency and you have to pass the frequency here. Okay, this will return you the answer. As you can see, the return type is int, and once it will return, basically it will return 0 if this prefix doesn't exist, or if it exists, it will return the count on how many words have this particular prefix there. Okay, how many words have this prefix, the count for that. So quickly let me run this also for you. As you can see, this clearing all the test cases. I've already segmented this solution. If you see here, yep, I have segmented in both Java and Python, and yeah, this is how it looks. Okay, as simple as that. So yeah, and that was all for this particular video. I kept my promise, which I made some days back, that I will be showing you one question at least where I will be doing the whole structure, that is a try structure from scratch, and we will be, seeing the exact use of it. Okay. I think in yesterday's question they did not use the data structure correctly. Okay, they should not be using try in such a case, but still they use it. Okay, I will put that video again with a try implementation, but that was not the right way in yesterday's question. But today's question is the exact implementation. Okay, it's exact application of the try data structure. For that reason, I got determined at the starting itself that I will make the video totally on try. I will not be showing you any other solution of the brute force and all. Okay, because they are already them. Okay, I don't have to show them again and again. For that reason, I decided to do this data structure, and I collected some material, and then I showed you the whole thing. Okay, the whole idea behind it. So take this one, save it somewhere. Remember, whatever I've shown you, this is not for only for this question. Through this you can solve many other questions. So if you want a sample, store it somewhere. Okay, in some context, if you need to use it, you have to just paste this whole part. Okay, the node class and the try class, and then you have to just create object out of it and start using it. Okay, as simple as that. So yeah, and that was all for this particular video. I have shown you exact implementation of the try data structure and how it is really the application of it. Okay, in autocomplete we understood how, if you insert one or two words, how the autocomplete works in Google search or in any other text editors, all that in the compilers. So this is how this is being done. Okay, this is the internal data structure that is being used. So we learned about it. We also learned how to get the prefix. Okay, the prefix frequency using this data structure. If you see, if so many words are having the common prefix, they will be stored only once, because of which we are saving on a lot of the data structure. That is a space complexity wise also. Okay, so that is another advantage of it. Okay, so yeah, that was all for this particular video. If you like my efforts, please subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.